So in this problem, we are provided with a rational fraction and we need to convert it into partial fractions. Before beginning, we will check whether if this given rational fraction is a proper rational fraction or not. Now that's very easy to do because if we look at the highest power of x in the numerator, so that's 2, and the highest power of x in the denominator is 3. So clearly the degree of the numerator is lesser than the degree of the denominator. So that means this is a proper rational fraction. Now the next task will be to factorize the denominator. So factorizing the denominator, we have x cubed minus 6x squared plus 11x minus 6. So this is a cubic polynomial. So its factors will be x minus 1, x minus 2 and x minus 3. That will be the product which will give us back the cubic polynomial. That means our rational fraction x squared divided by x cubed minus 6x squared plus 11x minus 6. So this can be also expressed as x squared divided by x minus 1 times x minus 2 times x minus 3. Now our goal is to break it down into partial fraction. So that means we will consider x squared divided by x minus 1 multiplied to x minus 2 times x minus 3 and resolve it into 3 partial fractions, such that the first partial fraction is given by a over x minus 1, plus the second partial fraction will be b over x minus 2, plus the third partial fraction will be c over x minus 3. So here a, b and c, these are the constants whose value we will need to determine now. So let's begin. We will consider that this is equation number 1. Now what we'll do, we'll multiply both sides of the equation with the denominator x minus 1 times x minus 2 times x minus 3. So this is going to give us x squared on the left hand side. On the right hand side, we're going to get x minus 2 times x minus 3 multiplied to a plus x minus 1 times x minus 3 multiplied to b plus x minus 1 times x minus 2 multiplied to c. Now to find out the value of a, b and c, we will consider 3 values of x. So let's consider the first value of x. Now we're going to choose the value of x in such a way that the second and the third term, this will go to 0. All we have to do is look for a term that is common to both b and c, the second term and the third term. So we see that x minus 1, this factor is common to both of the two terms. So if we let x minus 1 equals to 0, or we can simply say x equals to 1, then the second and the third term is going to go to 0, and this is going to help us obtain the value of I. So let's do that. So we'll substitute the value of x equals to 1 into this entire equation. So we're going to get 1 squared equals to 1 minus 2 multiplied to 1 minus 3 times a. So we have 1 equals to, 1 minus 2 will be negative 1 multiplied to 1 minus 3, so that's negative 2. This will be multiplied to a. So we have a, solving for a, we get 1 over 2. So that's the value of a. Next, we will try to find out the value of b. Now, to find out the value of b, all we have to make sure that the first term and the third term goes to 0. For that, we'll look for a factor which is common to both the first and the third term, and we see that it's x minus 2. So that means if we consider x to be equals to 2, then the first and the third term will go to 0, and we'll be able to easily obtain the value of b. So let's do it. We're going to substitute x with 2 into this entire equation. So we are going to get 2 squared equals to, so we don't have to worry about the first term. We're coming straight away to the second term. We have 2 minus 1 multiplied to 2 minus 3 times b. So 2 squared, that's 4. So 2 minus 1 will be 1. 2 minus 3 will be negative 1. So we have negative b. So solving for b, we get b value is negative 4. And finally, we have to find out the value of c. For that, we are going to choose the value of x in such a way that the first term and the second term goes to 0. So we can see here that the factor x minus 3 is common to both the first term and the second term. So we're going to choose x value equals to 3. So substituting, we get 3 squared, which is 9. So 9 will be equals to, we don't have to worry about the first and the second term. We'll straight away come to the third term. So we have 3 minus 1 multiplied to 3 minus 2 times c. So 9 equals to, so 3 minus 1, that's 2. 3 minus 2, that's 1. So we have multiplied to c. The value of c will be 9 over 2. So now that we have successfully obtained the value of a, which is half, b it's negative 4, and c is 9 over 2. So we can substitute this back into equation number 1 and we will get a required partial fraction. So let's do that. Then place of a we have half. So half divided by x minus 1 plus b. So b value obtained as -4. So we have -4 over x minus 2 plus c. So c value came out to be 9 over 2 divided by x minus 3. Therefore, we can finally say hence our original rational fraction, which was x squared divided by x cubed minus 6x squared plus 11x minus 6. So this came out to be 1 over 2 times x minus 1 minus 4 divided by x minus 2 plus 9 divided by 2 times x minus 3. So this is the required partial fractions. That means when we take our given rational fraction, this can be broken down into 3 partial fractions.